Hello everyone. Today we are going to discuss rational numbers. First we will see what is natural numbers. Natural numbers always begin at 1 and it goes on till infinity. So we are representing natural numbers as n. So the natural number starts from 1, 2, 3 and it goes on till infinity. Next is whole numbers. Whole numbers we are representing using W. So the whole number starts from 0, 1, 2, 3 and it goes on till infinity. So including 0 to natural numbers we get whole numbers. Next is integer. Integer we are representing using the symbol Z. So integers include negative numbers, 0 and positive numbers. So the integers consist of negative numbers and positive numbers. Next is rational number. Any number expressed in the form of P by Q is called rational number, where Q is not equal to 0. What will happen if Q is equal to 0? P by 0 is equal to infinity. So Q will not be equal to 0. Next is multiplication. We are going to check the multiplication. 0 into 2 is equal to 0. So 0 whole number, 2 is also a whole number. நமக்கு கிடைச்ச ஆன்சரும் whole number தான். Next இன்னொரு example, 4 into 5 is equal to 20. So 4 and 5 whole numbers தான், 20 whole number தான். So multiplication satisfy the closure property. Whole numbers are closed under multiplication. Next is division. 5 divided by 8 is equal to என்ன வரும் நமக்கு? We will get a rational number. 5 by 8 is a rational number. So rational number வந்து whole number கிடையாது. So whole numbers are not closed under division. Next we are going to check the closure property for integers. Integers na we have negative numbers, 0 and positive numbers. First நம்ம additionக்கு closure property check பண்ண போறோம். First consider minus 4 plus 7. Minus 4 is an integer and 7 is also an integer. So what is the answer? 2. 2 is also an integer. So ரெண்டு integer add பண்ணும்போது நமக்கு வர ஆன்சரும் integer தான். So next ஒரு example, minus 7 plus 2. இப்போ இதோட ஆன்சர் minus 5. So இதுவும் minus 7 integer, 2 integer, minus 5 is also an integer. Next we will consider two positive numbers. 3 plus 2 is equal to 5. So இதுவும் integer தான். 3, 2 integer, 5 integer. So the addition satisfies the closure property. So integers are closed under addition. Next subtraction க்கு check பண்ணலாம். 5 minus 2 என்னது 5 integer minus 2 integer தான். ஸோ நமக்கு கிடைக்கிற ஆன்சர் வந்து 3. இதுவும் integer. Next 5 minus 7. 5 is the smallest number, 7 is the largest number. ஸோ நமக்கு கிடைக்கிற ஆன்சர் minus 2. இந்த minus 2 integer தான். ஸோ next minus 2 minus 3 minus 5. ஸோ இதுவும் integer தான். ஸோ minus 2 minus 3 minus 5 இது எல்லாமே integer தான். ஸோ integers are closed under subtraction. ஸோ subtraction closure property satisfy பண்ணுது integersக்கு. Next multiplication. 5 into 2 is equal to 5 2s are 10. 5 integer, 2 integer, நமக்கு கிடைச்ச ஆன்சர் 10 integer தான். ஸோ இது closure property satisfy பண்ணுது. next ஒரு நெகட்டிவ் நம்பர் எடுத்துக்கலாம். -5 into 3 is equal to -15. So -5 and 3 integers. The answer -15 also an integer. Next -5 into -3. The answer is +15. So இதுவும் integer, -3 integer, 15 integer தான். So integers are closed under multiplication. Multiplicationும் நமக்கு closure property satisfy பண்ணுது. Next division. 5 divide by 8. நமக்கு இது வந்து என்னது rational number. So இது வந்து does not satisfy the closure property because 5 by 8 is not an integer. This is a rational number. So integers are not closed under division. Next we are going to check the closure property for rational numbers. Rational number க்கு closure property check பண்ண போறோம். First addition க்கு check பண்ணலாம். So let us consider நம்ம ஒரு rational number consider பண்ணிக்கிறோம். 3 by 8 plus minus 5 by 8 is equal to இது ஒரு rational number, minus 5 by 8 is also a rational number. So இப்போ இதை add பண்ணா நமக்கு என்ன கிடைக்கும்? Denominator ரெண்டும் சேமா இருக்கு. So LCM 8, 3 minus 5 is equal to minus 2 by 8. So minus 2 by 8 ங்கிறது நமக்கு rational number தான். So this rational numbers are closed under addition. Addition வந்து closure property satisfy பண்ணுது. So next நம்ம subtraction பார்க்கலாம். Minus 5 by 7 minus 2 by 3. இப்போ இது ரெண்டையும் நம்ம subtract பண்ண போகிறோம். subtract பண்ணா என்ன ஆகும்? LCM 7 3s are 21. இப்போ இது ரெண்டையும் multiply பண்ணும். 5 into 3 minus 5 into 3 minus 2 into 7. 2 into 7. நமக்கு என்ன ஆன்சர் கிடைக்க போகுது? minus 29 divide by 21. So 29 divide by 21ங்கிறதும் rational number தான். So ரெண்டு rational number subtract பண்ணும்போது நமக்கு கிடைக்கிற ஆன்சரும் rational number தான். So the rational numbers are closed under subtraction. Next multiplication. Minus 2 by 3 into 2 by 3. So இது rational number, 2 by 3 is also a rational number. So when we multiply, what is the answer? Minus 4 by 9. So when we multiply two rational numbers, the answer will be a rational number. Into the denominator மேலே வந்துரும், numeratorல இருக்கிறது கீழே வந்துரும். So இதை multiply பண்ணும்போது minus 6 by 12. So minus 6 by 12 is also a rational number. So this condition satisfies the closure property. But in our example பார்க்கலாம் இது minus 2 by 3 divided by 0 by 3. So இந்த கண்டிஷனுக்கு the closure property satisfy ஆகுதான்னு பார்க்கலாம். இதை எப்படி rearrange பண்ணி எழுதுவோம்? 2 by 3 into 3 by 0 வரும் இல்லையா? 3 by 0 is infinity. So not defined. So this condition infinity varum. So not defined. And next property is commutative property. We are going to check the commutative property for whole numbers. Actually what is commutative property means? If we change the order of the operands, the result should not change. See, we have A plus B. These A and B are operands. If we change the order as B plus A, also the result will not change. So this is the commutative property. We'll check for addition. 0 plus 5 is equal to we can write 5 plus 0. Here we change the order of the operands. 0 plus 5 is equal to 5 plus 0. What is the answer? 0 plus 5 is equal to 5. 5 plus 0 is 5. So the answers are equal. So addition is commutative. The addition satisfies the commutative property. Here we change the order of the operands. Next we will check for subtraction. 5 minus 3 is equal to 3 minus 5. 5 minus 3 is 2. 3 minus 5 is minus 2. So these two are not equal. So 5 minus 3 is not equal to 3 minus 5. Here we have plus 2, here we have minus 2. So these two are not equal. So the subtraction does not satisfy the commutative property. So A minus B is not equal to B minus A. Next is multiplication. So 3 into 2 is equal to 2 into 3. So 3 2s are 6, 2 3s are 6. So 6 equal to 6. We get same answer. Multiplication satisfy this commutative property. Next we will check for addition. 4 divided by 5 is equal to 5 divided by 4. Both are equal or not? 4 divided by 5 is not equal to 5 divided by 4. Because we will get different answers for both these terms. So 4 by 5 is not equal to 5 by 4. So division does not satisfy the commutative property. A divided by B is not equal to B divided by A. So this commutative property satisfies addition and multiplication. Next we are going to check for integers. First we will check for addition. So for integers we will check example. Integers minus 4 is an integer plus 7. 7 is also an integer. Integers have both negative and positive numbers. Minus 4 plus 7 is equal to 7 plus minus 4. So minus 4 plus 3 is 6. Minus 4 plus 7 is 3. And answer is 3. So 3 is equal to 3. So addition is commutative for integers. Next we will check for subtraction. 5 minus, we take a negative integer, minus 3. 5 minus 5 plus 5, this is an integer, and minus 3 is also an integer, which is equal to, we are changing the order, minus 3 minus 5. So plus 5 and minus into minus plus. So 5 plus 3, here we have minus 8. Minus 3 minus 5 is minus 8. Here you have plus 8, this is minus 8. So these two are not equal. So subtraction is not commutative. Next we will check for multiplication. 5 into minus 2. We will take a negative integer which is equal to minus 2 into 5. It's minus 10. This is equal to minus 10. So this satisfies the commutative property because both the sides the answers are equal. Next we will check for addition. Minus 4 by 5 equal to 5 divided by minus 4. Next we will check for rational numbers. For addition, A by B plus C by D is equal to C by D plus A by B. We should get the same answer if we change the order. So let us take 2 minus 3 plus 5 divided by 7. This is A by B plus C by D is equal to we will get answer 3. What is the answer? 7 3s are 21 as LCM. Multiply 7 2s are minus 14 plus 3 5s are 15. You multiply 7 and 3, which is 21, and cross multiply 7 and 2, 3 and 5. So answer is 1 by 21. Next we change the order. C by D. 5 by 7 plus minus 2 by 3. This is equal to, same, 7 3s are 21. LCM is 21. Cross multiply 5 into 3, 15 minus 7 2s are 14, which is equal to 1 by 21. So the answer is same, 1 by 21. If we change the order of the operands, also we get the same answer. So the addition satisfies the commutative property. Next, subtraction. 2 by 3 minus 5 by 8. A by B minus C by D, which is equal to, the denominator is LCM is 3 8s are 24. So cross multiply 8 2s are 16 minus 15. 3 5s are 15, which is equal to 1 by 24. Next, change the order. 5 by 8 minus 2 by 3. This is equal to, denominator is 8 3s are 24, 5 3s are 15 minus 16, which is equal to minus 1 by 24. Here we have 1 by 24, here minus 1 by 24. So these two are not equal. So subtraction does not satisfy the commutative property. Next, multiplication. 2 by 3 into minus 5 by 3. This is equal to, 2 5s are minus 10, divide by 3 3s are 9. Next, change the order. Minus 5 by 3 into 2 by 3. 3 3s are 9, 5 2s are 10. So both the answers are equal. So multiplication satisfies the commutative property. Next, we'll check for division. 2 by 5, take 3 by 7. So A divide by B, divide by C by D. What is the answer? Take LCM. 7 5s are 35. Sorry, you rearrange this. 2 by 5 into 7 by 3. This is in division form, so we are rearranging as 7 by 3. 2 7s are 14, divided by 15. So next we are changing the order. 3 by 7 divided by 2 by 5, and rearrange this as 3 by 7 into 5 by 2. 7 2s are 14, 3 5s are 15. So here we have 14 by 15, here 15 by 14. So these two are not equal. So this division does not satisfy the commutative property. And next is associative property. Associative property for addition. Let us take 7 plus 2 plus 5. A plus B plus C. The parenthesis for B plus C. This is equal to A plus B. 7 plus 2 plus C. Here we rearranged the parenthesis. Here the bracket is for 2 plus 5. Here it is for 7 plus 2. So what is the answer? 7 plus 2 plus 5 is 7, equal to 7 plus 2 is 9. Sorry, this is 5. 9 plus 5. So this is 14, equal to 14. So left hand side is equal to right hand side. So this addition is associative. This addition satisfies the associative property. Next we'll check for subtraction. A minus 2 minus 5. A minus B minus C equal to 7 minus 2 minus 5. Here 7 minus and 2 minus 5 is minus 3 and 7 minus 2 is 5 minus 5. So here 7 minus into minus plus, so 7 plus 3 equal to 0. So 7 plus 3 is 10 equal to 0. 10 is not equal to 0. So this subtraction does not satisfy this associative property. So A minus B minus C is not equal to A minus B minus C. Next is for multiplication. You take the same number, say 7 into 2 into 5. The bracket is for 2 and 5 equal to 7 into 2. We changed the brackets into 5. 7 into 10 equal to 7 2s are 14 into 5. 70 is equal to 70. So this multiplication satisfies this associative property. Next 7 divided by 2 divided by 5. This is equal to 7 by 2 divided by 5. So we can rewrite this as 7 divided by 2 by 5 equal to 7 by 2 divided by 5. So we can write this as 7 into, we are changing the division into multiplication. So 7 into 5 divided by 2, 7 by 2 into 1 by 5. So here the answer is 30. Then next is integers. For integers we are checking associative property. First we will check for addition. Minus 2 plus 3 plus minus 4. So minus 2 plus 3 plus minus 4. Minus 4 is an integer. 3 and minus 2 are also an integers, which is equal to minus 2 plus 3 plus minus 4. So what will be the answer? Left hand side we will get minus 3 and right hand side also minus 3. So A plus B plus C equal to A plus B plus C. So this addition satisfies the associative property. Next for multiplication, subtraction. 5 minus 7 minus 3, 5 minus, that is A minus B minus C equal to 5 minus 7 minus 3. Here minus 3 minus 7, 5 are integers, which is equal to 1. This side we will get minus 5. 5 minus 7 is minus 2, minus 3 is minus 5. Left hand side we will get 1 answer. So 1 is not equal to minus 5. So the subtraction does not satisfy this associative property. Next we will go for multiplication. 2, let's take 2 into minus 3, an integer, and the parenthesis for 3 and 5. This is equal to 2 into minus 3, close the bracket, into 5. So here we have 3 5s are 15 into 2, 30. Here also 2 3s are 6, 6 into 5, 30. So minus 30 equal to minus 30. So this multiplication satisfies the associative property. Next, for division, let's take integer minus 10 divided by, the second digit is 2 divided by 5. This is equal to minus 10 divided by 2 divided by 5. So this left hand side answer is minus 10 into 5 divided by 2. This side we will get minus 10 divided by 10. So this is equal to minus 50 by 2 equal to minus 1. So minus 50 by 2 is not equal to minus 1. So this condition is not satisfied. So division is not associative. Next we will check the associative property for rational numbers. First we will check for addition. Let us take 1 by 2 plus 1 by 4 plus 3 by 4. A by B plus C by D plus E by F. This is equal to, just we are changing the parenthesis order, 1 by 4 plus 3 by 4. We changed the order. Next we have 1 by 2. If you simplify this, we have 4 denominator 4, 1 plus 3 is 4 equal to this is 3 by 4, LCM is 4, so 2 plus 1 is 3, 3 by 4 equal to 6 by 4, this is equal to 6 by 4. So left hand side is equal to right hand side. So this addition satisfies the associative property. Next for subtraction, 1 by 2 minus 1 by 4 minus 3 by 4. This is equal to 1 by 2 minus 1 by 4. We have changed the order, minus 3 by 4. This is equal to 1 by 2 minus, if we solve this terms, we will get minus 2 by 4 equal to 1 by 4 minus 3 by 4. So 4 by 4, if you solve this, you will get 4 by 4 is equal to minus 2 by 4. So this is not equal to this one. So subtraction does not satisfy this associative property. Next is for multiplication, 1 by 2, 1 by 4 into 3 by 4 equal to 1 by 2 into 1 by 4 into 3 by 4. We have changed the order. The answer is 3 by 32, which is equal to, here also 3 by 32. If you simplify this, you will get 3 by 32. So multiplication is associative. Next we will check for division. 1 by 2 divided by 1 by 4 divided by 3 by 4. This is equal to 1 by 2 divided by 1 by 4 divided by 3 by 4. So this side 1 by 2 divided by this 1 by 4. Just we are changing this division into multiplication. So 4 by 3 equal to 1 by 2 into 4 by 1 divided by 3 by 4. So this side 1 by 2 into 3 by 1 this side two by 1 divide by 3 by 4. So 3 by 2 is equal to 8 by 3. So left hand side is not equal to 8 by 3. 3 by 2 is not equal to 8 by 3. So this condition is not satisfied. Next we will see the distributive property. Distributive property is nothing but when we multiply a factor with two terms which is inside the bracket, we need to multiply this factor with each of these two terms. So a is a factor, we need to multiply this a factor with the terms which is inside the bracket. A into b plus c is equal to ab plus ac. Next we will see the example. We will check the distributive property for rational numbers. First, let us take the value of a is equal to 1 by 2. Then take b is equal to 3 by 2. And c equal to 5 by 2. So we are taking the values for a, b and c. Now we will check this property. A into b plus c. Value of a is 1 by 2 and b is 3 by 2 plus c is 5 by 2. This is left hand side. This is equal to ab. 1 by 2 into b 3 by 2 plus ac. A is 1 by 2 and c is 5 by 2. This is right hand side. So 1 by 2, then simplify this one. Denominator is 2 and 5 plus 3 is 8 equal to 1 into 3, 3 divide by 2 2s are 4 plus 1 into 5, 5, 2 2s are 4 divide 5 by 4. This is equal to multiply 1 by 2 into 8 by 2. 1 into 8, 8 divide by 2 2s are 4 equal to, the denominator is same, so we are taking 4. 5 plus 3 is 8. So 8 by 4 is equal to 8 by 4. These two terms are equal. Left hand side is equal to right hand side. So this rational distributive property for rational numbers is satisfied. And this is for addition. We have checked the distributive property for addition. Next we will check for subtraction. A into b minus c is equal to ab minus ac. You take the same values for a, b and c. A is 1 by 2 and b is 3 by 2 minus 5 by 2 equal to 1 by 2 into 3 by 2 minus 1 by 2 into 5 by 2. So this side 1 by 2, and if we simplify these terms, denominator is same, so 2, 3 minus 5 is minus 2 equal to 3 by 4. So 1 into 3 is 3, 2 2s are 4 minus 1 5s are 5, 2 2s are 4. This is equal to, then multiply 1 by 2 into 2 by 2. So minus 2 by 4 equal to, so the denominators are same, take 4. 3 minus 5 is minus 2. So 2 minus 4 is 2 by 4 is equal to minus 2 by 4. Left hand side is equal. And next is additive identity or the role of 0. So generally when we add 0 with any number, we will get the same number as the answer. Let us take, suppose if we add 0 with the whole number, the answer will be the whole number. 0 plus 1 is equal to 1. 0 plus 2 is equal to 2. So if we add any number with 0, we will get the same number. So in general, we will say this as a plus 0 is equal to 0 plus a equal to a. When we add 0 with any number, it can be whole number, integer or rational number. When we add 0 with any number, we will get the same number as an answer. We will check for whole number. Whole number, let us take 7 as a whole number, plus 0 is equal to 0 plus 7 equal to, what will be the answer? 7 plus 0 is 7 and 0 plus 7 is equal to 7. So when we add 0 with the whole number, we will get the whole number. Next we will check for integer. For integer, we will take the negative value minus 3 plus 0 equal to 0 plus minus 3. What will be the answer? Minus 3 plus 0 is minus 3 only. So when we add 0 with the integers, we get the integer as the answer. Next, rational number. Let us take minus 3 by 5 plus 0 equal to 0 plus, the rational number is minus 3 by 5. What will be the answer? Minus 3 by plus 0 is equal to minus 3 by 5 only. So when we add 0 with any number, we will get the same number as an answer. This is the next we will check the multiplication identity, that is the role of 1. When we multiply 1 with any number, it can be either integer, natural number, whole number or rational number. When we multiply 1 with any number, we will get the number as an answer. If we multiply integer with 1, we will get the same integer as an answer. If we multiply any rational number with 1, we will get the rational number as an answer. We will write a into 1. That is a can be any number, either integer or natural number, and 1 into a equal to a. So when we multiply 1 with any number, we will get the answer as a. That is, it can be any number. So we will check for integer. Let us take a negative number for integer. Minus 7 into 1 equal to 1 into minus 7. So what will be the answer? Minus 7 into 1 is minus 7. 1 into minus 7 is also minus 7. So when we multiply integer with 1, we will get the same integer. Next we will check for natural numbers. Natural numbers we will take as a 5. 5 into 1 equal to 1 into 5, which is equal to 5. So when we multiply any natural number with a 1, we will get the same natural number. Next we check for rational number. 3 by 5 into 1. 1 into 3 by 5. So we are multiplying the natural number 3 by 5 with the 1. So we will get the same rational number as an answer. So 1 is called the multiplicative identity. Next we will see additive inverse. What is additive inverse? Let us take a, any number. It can be any number. And what is the inverse of a? It is minus a. Inverse of a is minus a, and additive inverse of a is a plus, that is minus a, which is equal to, we can rearrange this, rewrite minus a plus a, which is equal to 0. So additive inverse means when we add any number with its inverse, we will get the 0 as the answer. So the addition of any number with its inverse is 0 answer. So number 2, the inverse of number 2 is minus 2, and inverse of number 5 is minus 5. So when we add number 5 with its inverse, the answer will be 0. So this is called additive inverse. Next is multiplicative inverse, which is reciprocal. So multiplicative inverse means, let us take number a by b. So the inverse of a by b into c by d equal to 1. So where c by d is, this c by d is reciprocal or multiplicative inverse. So this c by d is called multiplicative inverse or reciprocal of a by b. So here 0 has no reciprocal. For 0 we have no reciprocal. So let us take number 5 by 15. So what will be the reciprocal of 5, 15? That is multiplicative inverse is 15 divided by 5. So number 5 by 15, its reciprocal is 15 by 5. When we multiply any number with its reciprocal, we will get the answer. What will be the answer? 1. So this is called multiplicative inverse. When we multiply any number with its reciprocal, the answer will be 1. So again we take 5 by 6. Its reciprocal is 6 by 5. So the answer is 1. 6 gets cancelled and 5 gets cancelled. The answer is 1. So this is called multiplicative inverse or reciprocal. So we need to. Next is representing the rational numbers on the number line. First we will see the natural numbers on the number line. Just draw a number line. This is actually the natural numbers starts from 1 to it goes on till infinity. So the natural number starts from 1, 2, 3, 4 and it goes on. So the natural number starts from 1 and it extends till infinity on the right side. So the natural numbers extends only on right side. So it starts from 1. Next is whole numbers. The whole numbers actually starts from 0, 1, 2, 3 and it goes on infinitely. So the whole number starts from 0 and extends on the right side, only right side. Next is integers. Integers we have negative numbers, 0 and positive number. So here you have 0. So this integers extends on both the sides. So 0, here we have positive 1, we have negative 1. 2, here we have minus 2. So it goes on, it extends on both the sides. So the integers extends on both the sides. Next is rational numbers. This is 0. The rational numbers also extends on both the sides, left hand side also, right hand side. 0, 1, 2, 1. We can say 1 by the rational number, so we can express 1 by 2 and this is 1 because 2 by 2 is 1. This is minus 1 by 2, minus 1. So it goes on both the side. It extends both the side. So integers and rational numbers extends both the sides. It goes on till infinity on left hand side and also right hand side. Now let us represent a number 2 by 5. This is a rational number. We are going to represent this 2 by 5 on a number line. So represent 2 by 5 on a number line. For that we need to find actually this where this point is located on a number line. To find that, just we are going to divide this 5. We are going to divide 2 by 5. So we are dividing 2 by 5. So what will we do? We cannot divide 2 by 5 by 5. So add 0. Here also 0. So remaining we have 2. So add 1 0 here. So 5 4s are 20. So this is 0. So here we are going to represent this 2 by 5 on the number line. Just draw a number line. So draw a number line and 2 by 5 value is 0. If we divide, we will get 0.4. So this 2 by 5 lies on 0.4. Let us draw 0 here and 1 here. So this point lies between 0 and 1. So this point lies somewhere around between 0 and 1. So we need to find this point 2 by 5. So what will we do? See the denominator, which is 5. So we need to divide this 0 to 1 into 5 parts. 1, 2, 3, 4 and this 5. 1, 2, 3, 4, 5. So denominator, check the denominator, it is 5. We need to divide this 0 to 1 gap into 5 parts. So the each line represents 5 points. So this is 1 by 5. This one is 2 by 5, 3 by 5, 4 by 5 and this is 5 by 5, which is equal to 1. So this point is located here. Next we are going to see the rational numbers between two rational numbers. We are going to find the rational numbers between the two rational numbers. Find two rational numbers between 2 and 3. So we need to find the rational numbers between these two numbers, 2 and 3. For that they ask two rational numbers. They ask only two rational numbers. So the given is 2. We can write this as 2 by 1 and this 3 we can write as 3 by 1. So we need to multiply this numerator and denominator. So here they asked two numbers, two rational numbers. So we need to multiply by 3. That is 2 plus 1. If they asked 3 numbers, you need to multiply by 4. So they asked two rational numbers. So multiply numerator and denominator by 3. This is equal to 6 by 3 and 3 into 3, 1 into 3, which is equal to 9 by 3. So the 6 by, we need to find the rational number between 6 by 3 and 9 by 3. What is the number? 6 by 3, 7 by 3, 8 by 3 and this is 9 by 0. So the two rational numbers are 7 by 3 and 8 by 3.